during the webinar. If you have a question, go ahead and put that in the Q&A window, and I'll commit to you if the question is not answered in line with the content that I'll make sure that you get an answer to your question. Also, thank you for those in the chat telling you about the audio. That's fantastic. Thanks so much. Also about the chat window, you could chat amongst yourselves, use that as a back channel, comment, or anything else, and I'll be asking a few questions throughout the webinar. I also understand that you guys are really, really busy people. Software architects, we also have some managers and executives here on the webinar, and we recognize your time is really valuable, and so we are not going to take up a full hour of your time. I'm going to blaze through this content and tell you what you need to know, and then get you on about your business. All right, so let's get going into the material. Let me just shrink myself so you can actually see the slides a little bit better, and let's rock and roll. So the webinar is going to be organized like this. We're going to walk through the challenge, some symptoms that you probably are seeing, a roadmap for database DevOps, go into some details there, and then talk about the value that it can provide for you and your team, and then offer up some assistance that we can help in your journey there. So here's the challenge. We have largely tools and processes that make applications flow through in a very short period of time. But for some reason, the database, the SQL Server database, is getting left behind, and that's not cool. We see lots of products that are out there for automated deployments, for instance, automated builds and automated deployments for applications, and specifically web applications, where essentially it's a file copy and setting some configuration settings. And we see demos all over the place of how you can just get up with these tools, get up and running really, really quickly. However, they don't touch on the database at all. And so we end up having complex databases that are still manually deployed, and they're kind of being left behind. So as an architect, you are responsible for the fitness of the software to the need that it's supposed to fulfill. You're accountable for the stability of the environment that you designed, and you're the one who must equip your engineering teams with the process for developing the software system, which includes SQL Server databases. And here are some symptoms on the left that you might be seeing: manual database deployments. Maybe there's a separate application and database process for DevOps for builds and deploys and testing and monitoring. And then you may have varying database schema versions. If you have a test database and then staging or QA or production database environments, and there's different variations in the schema, you may see that and it's causing issues. Well, we want to dive down and look at some of the common root causes behind these symptoms that are observable. And a lot of the there's three root causes that we see a lot in the clients that we help. And one is an incomplete development environment. And we're going to go into that coming up. But if the database is not even a part of the development environment, if the database is just kind of managed completely in a manual fashion and left out, then that can actually cause some of the symptoms on the left. Jump to the third: software configuration management not applied to the database. If you can't create the real database schema from the assets, from the scripts that you have stored in your source control, then you're not applying software configuration management to the database like you do with the rest of the applications. And then in the middle, and we'll talk about this a little bit later in the webinar, is an ambiguous enterprise architecture can actually be a huge root cause that just causes all of this to all the pain on the left to happen. So let's jump through. Here is our industry's model for DevOps, and I don't like it. It maintains two different teams and suggests smooth handoffs between them. And we've all heard, oh, DevOps is the coming together of dev and ops so that they can work together. Okay, but you still have a handoff. We prefer untwisting this figure eight and making the team one. This view of DevOps is integrated and shows a single cycle of stages around the outside, from planning all the way through learning by observing the impact that the change is making now that people are using it. It's the center, and in the center is the automated DevOps pipeline. It's the foundation. It is the axle around which our cycle spins. It's the core of our process architecture, the assembly line, the central pipeline through which ideas flow to become working software. But it's only a start. And it doesn't help us much if we are struggling with a big and complex database, because it just doesn't touch on it. So we have, at Clear Measure, we have a complete model for DevOps-centered software architecture, for DevOps-centered software engineering. And it's enabled by the automated DevOps pipeline, which must include your database and every other component of your software system. And there are 5 other layers that must be accounted for as well. Each layer must have a sound strategy, as you can see on the top left, a sound strategy, be faithfully and consistently executed, and be measured and tuned. And we've conducted other webinars where we go much deeper into the details of this model. And if you're interested in receiving a recording of that webinar, then you can ask us to send that to you. Okay. And some of you have asked to move. You know what? You probably don't want to see me as much, so why don't I shrink myself down? There we go. I can adjust myself. The magic of the technology. All right. So let's go ahead and oh, by the way, if you want that recording, just go ahead and put a question in the Q&A window, and we'll take note of that and make sure that you receive that. All right. Okay. So let's dive into the strategy for the core of our model, the automated DevOps pipeline. All right, it's coming up here. We see a good architecture for an automated DevOps pipeline, okay? And most of you on this webinar are architects. We have some development and engineering managers and some executives. You understand strategy. If you pick the wrong one, then it doesn't matter how good you execute the wrong strategy. You won't get the desired results. So when it comes to important technical decisions or the structure of environments and the structure of our systems, architecture is strategy. And a pipeline must support the scenarios you see in the box on the bottom left. We like to pack in many more capabilities, but if you don't have these, then there's going to be obvious gaps. You have a private build that can just run on an individual software engineer's workstation. Your continuous integration build shared amongst the team. Static code analysis, one of the 3 big quality and defect detection methods. Release candidate packaging, environment configuration, actual deployment of the application, application startup smoke tests and built-in self-checks, automated full system tests in a fully deployed environment, approval or auditing of production deployment, because that's when you're actually releasing it to your customers, and then configuration of DevOps diagnostics and monitoring, like centralizing all of your logs so that you have a clear view of what it's doing. These are basic capabilities of a DevOps pipeline, and your database has to be in every single one of them. So notice that in our scenarios, we don't mention anything about the database here explicitly, but we also don't mention anything about a web application. We don't mention Windows services. We don't mention Azure functions. We don't mention any application component type or specific infrastructure. And when you're looking to create a pipeline for an application, the pipeline must support everything that makes the application work, everything within the application box on your enterprise architecture. And I'll come back to that later. I'm going to show you an application that consists of a web application and a SQL Server database so that you can see how all this fits together. And then we're going to discuss some more complicated scenarios. So let's go through this briefly. Okay. So we start with how to store the source in your version control system. Every part of the application needs to be in Git. And if you're using Subversion or something else, okay. But for the modern applications that are first getting started, everyone's using Git now. If your system uses microservices or any other segmentation pattern, then you'll have multiple Git repositories, each containing a single versioned unit. And I'll just call this unit an application. The architectural relationships are that one team can develop one or many Git repositories, but one Git repository can only be developed by one team, even if it's large. And one Git repository can hold one application along with its components, whether it's a big, massive application or small, it's all version deployed together. And one Git repository should be built by one continuous integration build. The CI build will produce a deployment package for each application component in that single software application. The web application component, your database, your SQL Server database, your batch job or offline job, those all need to be deployed, but they're the same version and they're deployed together, and they are one application, even though there may be multiple components. So those relationships are important, because if you break those relationships or have multiple different applications in the same Git repository, or try to have multiple things that are built out of the same Git repository, then you're fighting against the way that the tooling is natively designed to operate. But let's continue. One build will have one deployment pipeline made up of no less than 3 environments. The 3 unique environment types are, and I call it test-driven development, or your acceptance test environment, manual test, and production. You can have multiple of each type, but at least one of each type. Now, everybody knows production, and everybody knows environments that you do manual testing on. But the first line acceptance test, or the TDD environment, that is the one that is new when you're putting together a DevOps pipeline that has everything in it, because you need this first line environment to be automatically deployed right away after your build runs, so that you can validate if the new build is actually deployable or not. It does you no good to attempt to deploy to a manual test environment just to waste a real person's time with a build that actually doesn't even work or doesn't even start up. So we need an environment right away that essentially validates that the new versioned release candidate that was just built can be deployed, does actually start up, and does actually function in a basic way before we promote it on and ask humans to spend their time with it. So you build a versioned release candidate once, and you deploy the exact same release candidate to each environment. This squeezes out variance and the surface area for bugs. In the TDD environment, we reinitialize the entire environment, including the database. And much of the time, this means dropping and recreating the database from what was in source control. And we're going to get to a demo of this in just a second. In the other environments, we migrate or update it with changes. Okay. All right, so these environments are important. Again, you could have 7 environments by having 5 manual test environments, but you need at least one of each of the 3 types. So you'll never have a pipeline with fewer than those 3 environments, one for each type. So if you see a DevOps pipeline that just has production or manual test in production, it's got a big gap. Now let's talk about the parallel workflow of our teams. Here's the portion of the process for branches. And we can enable any number of developers to make changes in parallel because of 2 enablers. 2 enablers. First, we branch from master and have our build and first environment active on all branches. Okay, so this is the sequential process from private build to pushing our change to the CI build to packaging it up and putting those application components in package management, and then moving over to a release and doing our first deployment. And so the second enabler is that each team member is equipped with a dedicated database. You cannot do database DevOps with shared databases. Just won't work. So most of the time, this dedicated database is on the developer's local workstation. Now, you can set up a development SQL Server cluster and have everyone have their own uniquely named database. But every developer needs to have their own dedicated database so that they can have a short inner development loop. And this ensures that the developer can recreate the database at will to get back to a clean state, and that any changes can be experimented with using a short cycle. The developer can push changes onto the branch and benefit from the full series of test suites, including a complete deployment. Because if you're adding a table to the database or adding some columns or expanding some columns, or heck, if you're removing some columns, doing some, you need to have your full suite of tests available to you so that you can get it right before you actually submit a pull request to get those changes merged over to master and where they would affect the rest of the team. So only changes that are merged back to master, by the way, would be eligible to continue beyond the TDD environment and be production level release candidates. And of course, you want your feature branches to be short-lived. That goes with any type of branch, regardless of the usage. So this is for feature branches for parallelism. Okay, so for the DevOps environment, here's the tools that you'll need for your DevOps environment to support the database. And in our environment for Visual Studio-based applications, Azure DevOps Services, Octopus Deploy, and Redgate SQL Change Automation. Now, if you know what you're doing, can you do it 100% with PowerShell scripts? Yeah, you could, but you're gonna drown in a sea of PowerShell. We're using Azure DevOps Services. We're going to show you that. We are using Octopus Deploy, which is a deployment server for the most complicated of deployments and is super, super powerful. Can you use the Release Hub for some simpler scenarios? Yeah, you can. And Redgate SQL Change Automation integrates nicely there. But Octopus Deploy, these combination really set you up for success. So let's get into the demo, and let me just show you just locally. If I pull up, and I have a working copy right here of what is an application called Clear Measure Bootcamp, and we have an automated build process in PowerShell, and it takes a minute and a half to run. I don't want you guys to wait on it. So this is the PowerShell build. And if I scroll down, it does compile, and I know you don't want to read all this stuff, but if we scroll down, we can see the durations, and up here is output from SQL Change Automation. I'm using 3.1.3, and you can see that what it's doing is it's creating clearmeasure.bootcamp, creating a database called clearmeasure.bootcamp, and then it's running the migration. It's setting up the schema from what is in source control. And if we look towards the bottom, after that, it runs migrations, and I'll show you those. And then I also have this window, and we have a helper called FreshDB, which essentially just calls a PowerShell function, which I'll show you. And at any time, a developer can call FreshDB and say, you know what? I want to recreate my local database from scratch, from what's in source control, and Redgate is going to spring into action, command line. By the way, you've probably seen a lot of demos of Redgate SQL change automation. When you're moving into the DevOps world, you want everything to be command line compatible. Okay. All right. And there's a few. I don't use the snapshotting in this configuration, so you saw that warning. But here we go. Database recreated. And now, by the way, I'm going to open this solution in Visual Studio while I'm showing you what this does. FreshDB is just a helper, and it goes to some PowerShell. And if I open this in PowerShell ISE and show you what that is, this is my build script. And by the way, this is a very generic .NET build script. It can work for any number. It's highly parameterized, and this has been my favorite build script template for probably 8 years now. Posted on my blog and whatnot at jeffreypalermo.com. But if I go to the tasks, which are FreshDB, I'm going to drop my local database, which you can see here. I'm executing a SQL command. I'm dropping the database, whatever database name I'm working with locally, and then apply local DB is right here, and we're going to call this PowerShell. And essentially, these are Redgate PowerShell wrappers. And essentially, with just a small amount of PowerShell, I'm going to recreate the database from scratch, and that's what does it. It's pretty simple. All right, and if I go into, as your Visual Studio is loading up, but if I go into, I'll just show you in source where this is, because this is in my Visual Studio solution. See, Visual Studio solution file, database, Clear Measure Bootcamp. We have a SQL proj, and then inside migrations, we have a baseline script, which is wherever your starting point is. And I'll happily show you that. Actually, I can probably show you with syntax highlighting if I just move over the Visual Studio window. If I show you baseline, open that up. Okay, let me shrink this down. And this is, well, we have an employee table, we have an expense report table. It's whatever we started with. And then we happen to have one particular change, which was a conversion. I had a database where I converted it from AliSQL, which is in line with DBUp and Roundhouse. And it has a database where it tracks the database scripts. And I just went ahead and got rid of that. So that's the one migration that I put in here. And if I come over and show you the database here, if it reconnects, there we go, as it comes back up. And I might have to reconnect here. We've got a lot of stuff running for this webinar on the workstation, but we are going to do a change, and might have to refresh this. There we go, because I dropped and recreated it command line. So the tables in our database is not a very big database, but the tooling, we've done this for clients with massive databases. And here we go. We have our employee table and expense report and things like that. So I'm going to talk about, I'm going to show you briefly the pipeline, which is made up of Azure DevOps services and Octopus Deploy. And so here's the pipeline, 1, 2, 3 environments. And I'm going to dig into that in a little bit. But before I do that, let me just show you the application. Go. Bring that up. And while I'm doing that, in sequence, what we're going to do from a development experience is we're going to make a refactoring. We're going to actually do a test-driven development change like we want our developers doing. And I'm going to add a nickname property to my expense object. And so I need a nickname field in my employee table. And notice how we can just create an expense report. This is a very simple, basic application. And there it is. We can see that we have version 4.1.3.21 deployed. We also have some other diagnostic information deployed here, what the database name is and what release it came from. And so 4.321, if we look at Octopus deploys, dashboard, just walking backwards, 4.1321, there we go. And if we walk backwards to our releases in the pipeline that we're looking at, we should be able to match up 4.321. There we go, 4.1321. And if we walk backwards to the build, then we should see in our integration build, yep, 4.1321. And here's the build. Okay, all nice and good. So that is what happens to be deployed. And so let's go and see our development loop. So let's go ahead and close these down. Okay, so our development loop, we want to add a nickname. So we have a well-factored Visual Studio solution. We have a core project, which has absolutely no dependencies on it except just basics. It does not have any data access to it. That's factored off. This is a .NET 4.6.1 application, which is cross-bridged using .NET Standard, which is using using Entity Framework Core 2. So when you get your .NET Framework applications up to .NET 4.6.1, that is .NET Framework version that bridges over with .NET Standard. And so that enables you to use all of the .NET Core libraries that are coming out, and you can use those in your existing applications. So that's what we're doing here. And I'm going to go to our tester. We're going to do some test-driven development here. And here is a test. And let me go ahead and run that test. But here's a test that is essentially making sure that we can persist an employee. We're spinning it up, giving first name, last name, email address, middle name. And let's go ahead and run that test real quick. And make sure it works. And it's so important when integrating your database with your application that you have integration tests that validate that all of your queries work. And if you're using an object relational mapper, then this is going to be easy. Okay. And by the way, there's a question. There's a question here while we're waiting here. Does this apply to on-premise TFS as well? Yes. And then do you have this in GitHub? There's an older version. Not everything is in GitHub, but we will be forking it over. We will be forking it over and sharing it that way. So let us know if you're interested in that. Okay. So if this is not cooperating. I just do have a lot of stuff. Oh, here it comes. You know, all the webinar stuff actually does kind of tax the system, but let's let that run. Okay, so it works. Now I'm going to say one dot nickname equals, what's a good nickname? Mongo. Okay. Now we go to our asserts, and I can just use the same pattern here. Nickname. There we go. And nickname, of course, this doesn't exist. Go. Does not exist, but we're going to go ahead and create it. All right. Perfect, beautiful. It just added a nickname to our object. Let's close that out. And now it should compile. We should be able to rerun this component level integration test, which it's going to round trip to the employee table. Okay. By the way, I'm going to open up the data in here just so you can see the table data. All right, one record, and there is no nickname column. So of course, we do not expect this to pass, but we expect it to fail. And this is taking a bit. Ran this right before without the webinar software running. Because we want to do the full test-driven development cycle where we see it failing, and it fails because the column doesn't exist. And so it's really important to equip our developers with a clean workflow. And Redgate SQL change automation actually worked inside Visual Studio in a really clean way. All right, here we go, finally. So we have invalid column name nickname. It's not a surprise. So let's go to open table definition. All right. All right. Well, this is loading. There's a question in the chat. What if you have 10 web applications that call one database? Do you add the database project to each application or separate the database call on its own? That is a very, very common scenario. And we cover it in just a bit. But yes, that as an architect, you've got to unwind that. And I'm going to talk about that as we go forward. So we have nickname in varchar. 10's fine. Okay, now let's go ahead and just do an update on that. And this is a Redgate SQL change automation window. We're going to go ahead and generate the script because I did this. This is the workflow that you're going to equip your developers with. This is what they're going to do. And it's going to show you the script that it's creating. And look over here. It put a new script with a timestamp in the changes. Okay. Look at that. Alter table nickname. Okay. Great. Save that. Go ahead and deploy the project. And basically deploy project means, hey, go ahead and migrate my local, you're not deploying it to any environment. You're kind of deploying it locally where your local environment is deploying. Okay. Attempting to deploy the patch. There's already an oh, I was doing something right before this. Okay. So if we go here and if we just execute this script, and I'll do a command line, we'll see that we can completely recreate it. Okay, it's going to be altering the employee table, and then we'll rerun our test. Okay, and then let's go ahead and rerun our test right here. Now that cancel that. Now that the column has been added to our database, because if it's been added, then we should be able to actually do this. And because we're using Entity Framework Core, by the way, if with default conventions, we don't have to do anything for the mapping. Okay. So now our test persisted. And so now we can go and add it to the UI and whatnot. But I'm going to go ahead and close this down because it kind of sucking resources. But that's the development workflow. And you really didn't see a whole lot of Redgate logos in Visual Studio, but it was there, tightly integrated, popping up saying, hey, you want to generate the script, and then using the SQL Compare engine under the covers to figure out what the alter script would be. Then it showed it to us, and then it popped it right into source control. And now when we go back to our migrations in the changes, boom, it's right there. Okay. And so we see that there is a new file right here that alter table, add nickname varchar 10. All right. So really smooth developer workflow. And then when we come up and do our source control integration and do a commit, I'll just use tortoise git to do a commit. I clicked on the wrong thing. let's do a commit dialog. What we can see is that we have a few changes, but then we also have a new SQL file, which is that SQL file. So I can add it here. And then if I want to look at what was changed, this is essentially what is going to be changed, and compare with base. And you can see that there's our alter table, add nickname column. Then you can see we made a change in one of our test fixtures that is actually saving through our data layer a object to the database with a nickname piece of data in nickname. And then we can see that the employee object that change as well. So we're equipping our developers with a really slick workflow. All we have to do is commit that change, and then someone else will pull our change down, builds the database just like we did before, using FreshDB, and it creates the database from whatever is in source control. And let me walk you through each of these pieces now that we're and I'm not going to run the full pipeline here because it takes 5 minutes. You just don't want to wait for it to get all the way through the environments. But let me just show you each individual piece. So let me edit this build configuration just so that you can see how these pieces are put together. We're going to do our build step. We're actually running the same PowerShell build as we do privately, which is going to do a compile, is going to stamp version numbers, and is going to publish our test results from our unit tests and our integration tests. Because if you, again, look at our private build that we run, we have 77 tests that run in this very small application. Okay. So when you're running your build, I showed you the PowerShell slug, which essentially recreates the database and packages it up. But if you want to do some other options, there are individual Redgate SCA tasks that you can put in here, and you can control additional aspects. Not necessary, because the PowerShell under the covers it's just so powerful and so simple. I left this copy artifact in to talk about not doing that. In a DevOps scenario, you can copy these off to the side, but a folder of files or your own custom zip file is really not what's going to serve you well. In the .NET world, the NuGet package is the format of the release candidate. And so we want to have those packages, and we want to suck up all the packages and push them into Azure Artifacts. Okay. Now I'm going to show you what those look like, because I have them, I produced them here. Of course, they're not versioned because I produced them locally. So you see, version 1.0.0 instead of 4.1 point something. But, you have, I'm just going to show you one at a time, because, this is going to be your normal website package, and it's very common. If the NuGet Package Explorer will come up here. Actually, let me open this one. All right, I'm going to open the local package, and here is our database one, and here's the website one. So if any of you are familiar with an ASP.NET MVC project, that's essentially a web application. Pretty darn simple. And then you come up, and here is the database package. Now look at this. Here is our package that essentially represents a deployment package for our SQL Server database. This is it. This is it. And so what we have here, and I'll show you the important parts where you can see how this is flowing through. This is the information from and the scripts from your migrations. Now, this does not include the new one that we just created. This was from the build that I just ran right before we did our nickname change. But you see that new script would be right in here. And baseline is wherever you started. So essentially, there's one migration script since I initialized this new one. But if we're deploying or recreating it in our TDD environment, then this script is going to be run, and then this script. And just you want to view the content, there it is. We're going to create the employee table, then create expense report table. And that essentially has all of the schema scripts necessary to create that baseline and then the one change that we did. Okay, so that is the package format, and we store it in Azure Artifacts. And so if I want to move over to the release, no, let's do it here. Move over to the release configuration. You can see that we have our 3 environments. If I were just to, you can see kind of you can see how it's been run many, many times. We have our release configuration, test, staging, production, and how we have it integrated with Octopus Deploy. You can do all of this here, but Octopus Deploy has such a humongous library, and it's been around. It's such a mature deployment tool that the sophistication of deployment scenarios is still catching up in Release Hub, and so Octopus Deploy is just a dream to work with. You don't have to write hardly any PowerShell. It's just so powerful. So to start, by the way, let me talk about why we're integrating Azure DevOps Services with Octopus Deploy for the database. But we are using Azure DevOps Services as the whole orchestrator, and Octopus Deploy is doing deployments. Octopus Deploy is not a build server. Octopus Deploy does not run tests. Azure DevOps Services runs tests. So if we go and edit this again, and we go into our test environment, we are telling Octopus Deploy, hey, go do your thing, go deploy. Then what package are we downloading? We are downloading our acceptance test package, because now that we have a fully deployed instance of our application with a fresh database completely initialized, then we can just update some config and then run our acceptance test suite with InUnit or XUnit or what else, and then publish our test results. So that's what we're doing here. We are actually running tests after we deploy the application. That is so important. And your tests, you can run them in Visual Studio, but your tests are going to set up test data. They're going to set up test data, run a scenario, and then move on and reset up the data. So your test suites are actually putting the test data in place. We don't haul around this big set of test data for test environments. We want just enough data for functional testing. And so that data is initialized in your test suites, not in a database deployment. We don't deploy data to environments. We deploy schema to environments. And there's a question, where does the data get persisted in the project? The data does not get persisted in the project. You do not want to put data in source control or anything environmental specific in source control. Data has to be managed by your test suites, not by your database deployments. Now, there is another product called SQL Clone and SQL Data Mask that we're not covering on this webinar that do help if you're not ready for test suites that manage your own data. You can clone a production backup while at the same time using data mask configuration to expunge any sensitive information or anonymize it or clear it out or mask it so that you can get a big and representative big set of data from production back into a pre-production environment without security risks by getting rid of the sensitive data along the way. What you don't want to do is just do a straight restore, and then you got all kinds of sensitive information. So those products do help with that. Those would be separate from the DevOps pipeline. The DevOps pipeline is forward moving. It's make a change, move the change forward into production, but we preserve data in our manual test environments and our production environments. In our TDD environment, we are blowing away that database and recreating it from scratch, and then letting our test suites insert data as they run tests, and even insert test data sets. Now, at the same time, if you do want some generic vanilla data to always insert into your database, which is a common scenario for tables that hold, say, the list of states in the country or populate drop-down lists. Then you can absolutely do that by putting in whatever you want. I'll show you where in the tree it goes. In your post-deployment, there is a finalized deployment SQL file. Whatever you put in that SQL file will get run every time at the end. So if you want to add additional data or make sure data is there, then you can do that. Or if you're creating a new database and you want new things to be in a dropdown, then you could absolutely create a custom migration script that all it does is add a few more rows to a table so that you have a few more things in a drop-down list in your application. You only want to do that for things that do not vary from environment to environment, where you can say, you know what, that table is really application configuration. That table is not environment-specific data. So you do have hooks where you have flexibility. You can do things like that. Okay, so we've done this. This is our test environment. So let's move over to Octopus Deploy, because in our test environment process, now we're telling Octopus Deploy to create and deploy the release. So what we're doing is we're going to migrate the database, and what we have here is a process. Part of the process is going to run on the database server via the tentacle, and I'm not going to go too much into Octopus Deploy details if you've never done it, but we're essentially getting the package ID that is database.clearmeasure.bootcamp for whatever release number that we're on. So see how if I go back to the names, you see how the name matches up, and then the version number, that's how it finds the NuGet package in Azure Artifacts. And this is the package feed. You can have all kinds of different package feeds. Okay, so then once we have the package, we are doing two simple little things for this environment. We are dropping the database for the TDD environment, and then we are essentially running the built-in deploy.ps1. Now, if I show you what that looks like, if we go to bin release, now this Redgate generates this file, and essentially this file is really, really friendly to Octopus Deploy, and it's not going to walk you through it in entirety, but it essentially does the heavy lifting of running a migration script if it has not been run before. So this is Redgate's PowerShell file that can run command line in order to essentially look at every migration script, look inside the target database, and ask, hey, have I already run this? Have I already run this script before? If not, then run it. Now, if we look in here at our tables, we see a migration log. And if I pull up the data here, we see well, this is my local database, but in a downstream environment, this would be populated with rows, and there is a log in each downstream database that contains the scripts that have already been executed on that database, so that Redgate knows not to execute them again. That's how the same database deployment package can be run on multiple downstream environments. Okay, so that's how Octopus Deploy does its thing. And then in the TDD environment right afterwards, we essentially have we pull the integration tests package, which is a NuGet package, and it has, it automatically runs because of its deploy.ps1 file. And by the way, Octopus Deploy, if there's a deploy.ps1 file inside the NuGet package, then it's going to automatically be run at the appropriate lifecycle stage. And so we can see, well, there's a lot of stuff in here. Let's see here. We run our our tools, we're going to run the NuGet console runner. And that is essentially going to run against our integration tests config file right there. And so that is going to execute our process. And so Octopus deploy is going to pick up post deploy.ps1, and it's going to set the connection string. And then essentially it's going to call in unit 3 console with the integration test where the category is data loader. So we have in our integration tests a C# test fixture, which throws in some data into the database to initialize it. You can use whatever process you want and kick it off with a PowerShell file that's inside your package. What's powerful there is you're keeping more and more of your deployment logic in source control. And by the variables here, we're keeping it independent. Okay. And so, by the way, in our variables, we can see that we are controlling the database server, and this is demo, so the servers happen to be the same. Account password is encrypted, so it's not available. And we can have variances. For instance, and this is just terms that I kind of created. On the test environment, we want to rebuild the database. And on the staging and the production environment, we only want to update the database. Okay. So back here, now that we've created and deployed that release, we're running our tests in our staging environment. We only deploy the release, and we tell Octopus deploy the release. Notice that Azure DevOps Services is passing the build number to Octopus deploy so that we know which one. And then we're just doing a quick web performance test to make sure that it doesn't bomb and it spins up and it gets going. And then in production, just, hey, Octopus, go ahead and do it. But we are actually adding, if I go back to pipeline, we're actually adding a approval step. So pre-deployment approval so that somebody has to click a button to actually do it. So Azure DevOps Services is completely in control. I want to show you one other thing. Redgate, it kind of sits nicely embedded in, it doesn't take over your environment. It fills a necessary role. And, over in Octopus Deploy, just like in Azure DevOps Services, if you don't want to do it PowerShell, if you want a little bit more support, there is deploying packages, or deploying from other databases. There's all kinds of custom steps that you can do. And so Redgate has really good support for Azure DevOps Services as well as Octopus Deploy. But at the same time, everything that SQL Change Automation is doing can be run from command line, from PowerShell. So if I were to come here and just look at this latest release, and then look at the logs. Let's see here. You see our 100% of our tests passed, 100% test passed. That's good. If we were to look at our logs and we can download package, create an update release. There we go. These are the part of the logs that are streamed back from Octopus Deploy. So with the integration, everything that we are doing in Octopus Deploy is captured in the Azure DevOps Services logs so that we only have to look at one place, Azure DevOps Services, which is orchestrating the entire thing. And so as we look down, we can see that, we see some interesting stuff going on here. We see creating primary keys. We're adding our expense table. We're adding our expense report table, our employee table, things like that. And then we are executing our data loader that is putting data into our database via an in-unit test fixture in C#. And then the next task is downloading the package of acceptance tests. And then the next pass is poking a config. And the next is actually running our acceptance tests, which, by the way, happens to use Selenium to bring up a web browser and click buttons. And we only have one test here just to make sure we have a test suite. And so test pass, one test passed. So that's how it all puts together. I know I went into way too many details, but that's how it all fits together. And if I come back to CM Bootcamp Test Web, then we can see that running. And it is on version 4.1.321. And if I go over to production, CM Bootcamp production, I just happen to have unique URLs for all these guys just to make the demo go well. We have diagnostic information at the bottom, what database name that we're using, because in the DevOps world, you are recreating environment. You're recreating everything from scratch all the time environments. So you need to have all kinds of names parameterized. So, production is still on 4.1.317 and test is on 321. You want to know that. And as people do bug reports, you want to know the versions there. Okay, let's go back to our PowerPoint. We've got to get you guys out of here. And so we have a full model here for database DevOps. And you saw how Redgate SQL change automation just made the process seamless. But the architecture layer is so important. Now, let's talk about the big elephant in the room for a lot of people. What if your database is your system? What if you have one database, what if one production database and 10 applications have connection strings to it? Well, whether or not you would like it to be that way, for an application to have an automated DevOps pipeline, everything about it has to be under version control in the same way. So you have two options here. One is you pick one application that will architecturally own the database. And sometimes you can do that. And you can say, okay, this database actually belongs to this application, or maybe you call it a software system because the application is so big. And then these other applications, unfortunately, they have the connection string to it. And while we would love them to use more maintainable APIs, the APIs for integration that they happen to use to our main application is T-SQL and a connection string. So while it's unfortunate, architecturally, let's recognize that we have created that we have made the connection string an actual API surface. And then in that case, you can say, okay, well, at least let's recognize our reality. And then you can have that database schema put in with the main application that you now declare that it owns it. Now, in some cases, we have clients where it is the reality that no application can own this database. Maybe this database has tons of DTS packages and all kinds of stuff. There are quite a few cases where, from an enterprise architecture perspective, if we were drawing boxes on a whiteboard and saying, okay, what are all of our systems out there across our company? We would draw this SQL Server database in its own box. And we would have to recognize that we have an entire software system that is essentially implemented using SQL Server as a platform with DTS packages and scheduled stored procedures via the SQL agent and SSIS and reporting connections. And yes, we have other applications that use the connection string to integrate with it. But that SQL Server is a system in and of itself. So if we recognize that that's the case for some databases, then we need to create an automated DevOps pipeline for it. And it needs a Git repository. And then essentially it becomes a software application or a software system, whatever term you want to use. It has a Git repository. We equip it with a private build. We equip it with a continuous integration build and a automated deployment mechanism with environments down the line and all the techniques that I showed you. It won't have any .NET code in it if it's just the database, but we will give it a version number and we will be able to deploy it. And then if other applications need to integrate with it, well, guess what? Now we are producing NuGet packages with versions of that system. So if for a time before we can have a better architectural structure down the line, we at least have the ability to version, build, package, and deploy that database. And then for other applications that depend on knowing details about that schema, those applications can consume the NuGet package of the database pipeline, and they'll benefit from knowing what version that they are integrating with, and they can actually get the schema from the NuGet package because it's bundled up, and they can just depend on it just like any other NuGet package. And then those applications can actually create a read-only copy of that database from the scripts in the NuGet package and use it for their development. And then you break some of that coupling with the environments of that database system. And that is a reality out there. And so that scenario does exist. But the point is, you need to recognize what your independent software systems or software applications are, and give each one their own Git repository and their own automated DevOps pipeline. Okay, so there's so many companies that we've helped with this, and with great results. And we'd love for you to be one of them. And we'd love to be your guide. You have really important projects going on. We'd love to guide you through them by giving you an assessment, a review of your software, your database, or helping you out with a modernization roadmap. One easy way to get some help from us is to have us do some architecture level advisement or consulting. If you'd like a second pair of eyes on your database environment, we'd be happy to help. I love doing that. If you have any questions, here is my direct contact information. I invite you to email me. I invite you to call, and I'll leave this up for a bit. I will get to all of the questions, but I know I actually did run a little bit longer than I had expected. A lot of information here, but thank you so much for your time. And if you would like a copy of these slides, or if you would like the poster, the DevOps architecture, let us know that and request it from us. And thanks so much for your time. And then I'll go to the questions here for any of you who want to stick around. And I know quite a bit of questions have come through, so let me just go through them one by one. Let's see. I see the same kind of division between ops and dev. You now make one with the circle. I've seen the same kind of division between design and dev. Would you make that one big circle? Yes. There are different types of people. There are a certain type of person who is the customer, who's going to invest in it, who's going to say, I have this goal. Then there's the product management type, which really decides some of the details of build. And as an architect, you participate in that. And then there's the engineering, which actually builds it, actually makes it happen. But other than that, it's just details and skill sets and specialties. But we all need to be one team, not individual teams. Okay, let's see. Next question: If you have a database only DevOps pipeline, would you make it automatically deployed? Well, the TDD environment, that first line deployed environment, absolutely. Once you build something, you want to make sure that it is actually deployable and can be recreated from scratch in an environment, or have the environment recreated. If you can't recreate the environment, then you're not setting up the team for a DevOps workflow. And if you can't recreate your database environment, then there's absolutely no disaster recovery strategy, because you kind of have to be able to create that stuff. All right. Another question: can I get a link to the recording? Thanks, Adam. Absolutely. We'll send out a link to the recording. And then another question from Tim: can this be done with TFS 2018 instead of Azure DevOps? Yes, absolutely. TFS 2018 has most of the pipeline features, and Azure DevOps Server is coming out soon, which is such next finish, easy deployment for a local build server and DevOps deployment server. But it can be done with TFS 2018. Octopus Deploy does integrate with TFS 2018 as well as Redgate SQL change automation. And by the way, I showed you, you can use the Redgate step templates, but I wanted to show you just using the Redgate PowerShell because of how simple and how seamlessly it integrates. There's power in this process, and Redgate goes really far to not take over your environment or have to convert and say, I have a Redgate only environment. It fits in really, really nicely to manage your database DevOps and integrate with all of the other stuff that you have going on. Ruben, yep, we'll send out a recording. Thank you. And let's see, another question. We have our pipeline architecture very similar to what you recommend. However, we use Entity Framework migrations that will update the database upon deployment to any environment. What are the major benefits of using Redgate SQL change automation over Entity Framework migrations? Entity Framework migrations does work well when the only thing in your database is what you have mapped with your Entity Framework context. And so Entity Framework migrations are more limited to that scenario. Redgate SQL change automation can handle anything going on in your SQL Server database, regardless if you're using Entity Framework in Hibernate, Petapoco, Dapper, any kind of data access layer, or whether you just have a batch style offline job, it'll support anything. And for databases that have been around, over a decade and have a certain history about them, there's going to be some interesting things and different layers of database architecture and database methods along the way. If the database was created around the turn of the millennium, it's going to have tons and tons of stored procedures because that's just what the industry did then. I created a ton of stored procedures in my day as well. Redgate SQL change automation can handle absolutely every scenario in your SQL Server database, whereas an object relational mapper coupled migration tool can work for the scenarios that are tied to that domain model that's mapped in those classes. All right. Any other questions? Let's see. Suite of management tools. Looks like I answered. Okay. All right. I think I did answer all the questions. So I really appreciate your time. And again, this is my direct contact information. Take a screen grab, write it down, hit me on Twitter. And I appreciate your time. And if we can be of any help, then please reach out, even if it's just to get some advice on something. And I hope everyone has a great day.